be sort of confusing in a sense, but it's really nothing different than what you're used to, okay? It's just, we're gonna solve an equation for a variable just like we've been doing. The only difference is with the type of problems that we're gonna see today, instead of having numbers in situations, you're gonna have letters as well, okay? Whereas you can see on the board, we've got that ax minus b is equal to c, right? That's all letters, okay, but we're still trying to solve for x. Okay, so all the literal equation is an equation, with multiple variables. Okay, an equation with multiple variables. And we should be at this point, after working multi-step, Joe, if you need a pencil, I got some over there. Should be at this point comfortable-ish with two-step equations. This is something, we've even gone up to multi-step so far in class. Trevor, you got notes?
I have no idea what I'm doing.
Huh?
I have no idea what I'm doing.
You got paper? You got any paper? I got paper over there. You can just sit there. All right, so we should be comfortable with this after doing up to multiple step equations, okay? So when we see a problem like 2x minus 5 is equal to 13, okay, we'll need to add 5 to both sides. Okay, we'll have 2x is equal to 13 plus 5, which is 18. Divide your 2, and you got x is equal to 9, okay? This is the type of problem that at this point, you should be able to do on your own. You should be able to solve this on your own and be successful with it at least 75% of the time, okay? But this problem right here, this 2x minus 5 is equal to 13, is the same exact thing as ax minus b is equal to c, right? One has numbers, one has variables, okay? So if I was trying to think of how to get x on a side by itself, right, I know I need to get b to the other side, okay? So you're gonna do the opposite and add b. All right, you got ax is equal to, are these two like terms, c and b? No. Okay, so you've got c plus b.
No, I wouldn't, I see why you would do it now, because it's not number.
Right, and these aren't like terms, so you can't put them, you can't actually put them together, right? So it's just gonna be, you'll see that they're added together by doing c plus b. Okay, and then if we think of our last step here, what is happening with this a and x?
It's gonna be divided by.
You're gonna have to divide because this is multiplying, a times x. So to get rid of a, you're gonna have to divide it away, okay? So you're gonna divide by a. All right, then that will cancel, right? And you end up with x is equal to c plus b over a, right? You can't actually divide c by a because those aren't like terms. You can't actually divide b by a because those aren't like terms, right? All right, so some similarities in working with these. Both use opposite operations. To solve for the given variable. If you look at this problem, it told us it wanted us to solve for x. Okay, we used our inverse operations to get x on the side by itself. You'll also notice the difference here is that literal equations, the one with variables, literal equations don't simplify nicely due to multiple variables. So where we sometimes get used to it just being x is equal to 9, right? Or your variable is equal to one number. Okay, here this is much more messy, right? Because you've got x is equal to a bunch of stuff on the right side because it's not going to simplify as good with having multiple variables. Okay, so the process that you're trying to think of when you're working this literal is the same thing, and I'll give you some sort of scenario to kind of help you out, especially with it's a two-step like this. All right. So if you're Adrian, right, and you've got girlfriend with you, okay, you're going to the movies, okay. Here is Adrian. Here is Adrian with his girlfriend, right? That's Adrian with his girlfriend. Okay. This is Adrian's side piece, right? Adrian shows up at the movies. He's with his girlfriend. All of a sudden, side piece is there. Okay. What's Adrian's first thought? Adrian's thinking, I've got to get this girl out of here, right? So Adrian's going to get her out to the other side of the equal sign. Okay? All right, but what's Adrian's girlfriend going to do when she sees that he has a side piece, right? She's going to split, right? So you're dividing away that A. Okay, what's Adrian left with? 2 movie tickets and a broken heart. He's all by himself. All right, that's the way you got to think of these problems. Okay, you're always trying to go through this process of how do I get down to the variable by itself. Okay, so for a problem like that, that's a great example of how do I get Adrian by himself. X equal to C plus B over A. Does that make sense? All right, let's move on then. All right, so looking at number 1, we are supposed to solve for W. We want W to be on the side by itself. Okay, so if we find W up here on the board, right, we've got A is equal to L times W. Okay, length times width is really what that stands for. Okay, this is the formula for area, and this is when all this stuff starts to make sense on why would I move around a bunch of variables. Okay, say that you're on a construction site, right? And you know how big the area is that you're trying to pour concrete in. Okay, so say we're trying to pour concrete in this room. Okay, and I know what the total area of this room is, and I know what the length of this room is. Okay, but I don't know what the width is, and I forgot my tape measure at the house. Okay, how do I rework this formula to figure out what the width is? Does that make sense? Okay, so here I'm trying to solve for W, trying to solve for width.
You gonna divide that L.
And you're gonna divide your L away, and you're gonna divide your area times your length, and you'll figure out that your width is whatever your area divided by your length is. Okay, and now we've got W all by itself. Okay, so just doing these inverse operations, trying to get your variable on the side by itself. Trevor, what are you asking? All right, same thing with number 2. Okay, number 2, you've got A is equal to B times H. We want to solve for H. Okay, well, B and H are being multiplied together because they're touching like that. Okay, so we need to divide away our B, and you end up with A over B is equal to H. Okay, are these 2 things the same thing?
Yeah.
Yes or no?
No.
Yes. Right?
Wait.
A over B is equal to H.
It just flipped around.
It's just flipped around.
Cause, yeah, your
Okay.
answer in front of what you eat.
Right. So on today's work, and we're not there yet, okay, but for today's work, we're gonna be on Go Formative instead of Khan Academy, okay, and on that, I will have it, I believe I've got it either way, okay? Sometimes it's better just to do this way, just to be safe, but they're the same answers. All right. Number three, we've got, distance is equal to rate times time, okay? So we're gonna try to solve for the time, which means that we're gonna have to divide away rate. Do you have to know what these formulas stand for? No, okay? Because all we're trying to do is get our variable on the side by itself. Trevor, pull your mask up. So you got D over R is equal to T. Okay, notice my T here looks a little funny. That's because I don't want my T's to look like plus signs. Okay, so that might be something that you get in the habit of yourself. Same thing with a Z. If you think of a Z, put a line through your Z, so that way you don't think it's a 2. Okay, just a little math tip. All right, so if I look at 4, okay, I'm trying to solve for T. Okay, we've got T over here on the side with P and R and T.
So you're gonna divide by the P and the R.
Divide by the P and the R. Why am I able to do both?
Good.
Because
Right.
all three of these are being multiplied by each other. This is P
And
times
you
R
saw-
times T.
And then you wanna put the T because that's what you're solving.
Right, and you don't put the T because that's what you're solving. Okay, so you've got I over P times R is equal to T. Alright, same sort of deal with number 5. We're trying to solve for H. Well, H is being multiplied by L and W, so we're gonna have to divide L and W. Okay, and we end up with V over L times W is equal to H. Alright. Alright, any questions there? Because 1 through 5 are sort of similar, and we'll look at something different on 6. Any questions on the first 5? Alright, number 6, we are trying to get R on a side by itself. So what would be, this is gonna have 2 steps to it. What would be my first step?
Divide by the pi.
Divide by pi. Okay, we want to divide away the pi. Okay, and you've got A over pi is equal to R squared.
So now you're gonna do the square root of R squared.
That is great. I was hoping somebody could tell me that. Okay, so the opposite of squaring a number is to take the square root of a number. So you're gonna take the square root of both sides. Okay, and this will become the square root of A over pi is equal to R. Okay, so if you guys do the inverse operation and you see a square, you know that the inverse of that is going to be the square root. All right, another 2-step one here is number 7. What would be my first step?
Add S on both sides.
Okay, we're going to add S, and I was looking at the wrong variable, so this is just going to be a 1-step. I was thinking we were solving for S. So this is going to be M plus S is equal to C. That's all we had to do. So only 1 step. I thought we were solving for something different. All right, number 8. Okay, we want to solve for M. We've got a fraction, so we know a fraction means that what operation is happening.
Multiply.
What's actually happening is division, and we need to multiply. Okay, so we're going to multiply by our denominator, which is V, to both sides. All right, so here's where this is a little bit different than addition and subtraction, is you can multiply V times D and make it look like VH or RT, right? And so this would be VD is equal to M. And VD is equal to M. Any questions there? All right, let's look at this next one. Okay, so again, we're trying to get our variables on the side by itself. Okay, we will first, all right, solving for H, okay, so what could be a first step? What would be my first step? Any guess? Any Google guesses? Huh?
Multiply.
Let's multiply. Okay, what do we need to multiply by? Huh? Alright, we're trying to solve for H, so we need H to still be on the side by
No,
itself.
divide, you gonna divide two.
I agree with you on the multiply,
Oh,
okay? We need to multiply to get rid of this fraction, so what do I have to multiply by?
the A.
What would get rid of this fraction here? Two. Okay, so I'm gonna multiply both sides by two. I'm multiply both sides by two, and what that will do is get rid of my fraction on the right side, and I'll have 2A is equal to B times H. Now, where a lot of y'all were trying to go to,
It's B. Now we divide by B.
now you divide by B. Okay, now you divide by B. I think a lot of y'all are wanting to start with that step, which you don't need to. Okay, so you got 2A over B is equal to H. Alright, I guess you could have divided by B, it's not gonna change anything, in the end, it's just a little bit easier on your mind if you go left to right, okay? So I suppose you could have started with B. So. Alright, so number 10, similar to number 9, what would I need to do to start? Multiply by what?
3.
3, your denominator, okay? Multiply by your denominator. You got 3B is equal to B times H.
Alright, so, well, now I know, cause you solved for B, so.
Solve it for
divide.
B, so I need to divide by
H.
H. I want to get rid of H. So we got 3B over H is equal to B. Alright, number 11, okay, what should I do first? What do I have? What is this whole thing?
You gonna multiply by 2.
Multiply by 2. I have a fraction, so I need to get rid of the denominator, which is 2. Do that by multiplying by 2.
2K.
So you got 2K is equal to M times B squared. Alright, I'm trying to solve for
You
M.
bring the B, you gonna divide by the B squared.
Divide by B squared. Okay, so you got 2K over B squared is equal to M. Now, do I have to take the square root on this problem?
No,
No, why not?
because it's.
M's already on the side by itself, right? The only time you're doing these operations if you're trying to get to the other side, okay? All right, so looking at 9, 10, and 11, okay, we multiplied by the denominator, which was 2, multiplied by the denominator, which was 3, and multiplied by the denominator, which was 2, to get rid of our fraction. Okay, so we're multiplying by the denominator to get rid of fractions. So if I look at 12, and I have a fraction with a denominator of D, what do I have to multiply by to eliminate D? Huh? D. Okay, so you're gonna multiply by the denominator D. Okay, this is gonna be D times A is equal to B plus C. Okay, now if I'm trying to solve for B, what do I need to do next? Huh? Subtract C. Subtract C. Okay, so you got D times A minus C is equal to B. Alright, any questions on 9 through 12? Questions 9 through 12? Alright, let's move on. Alright, so solving for W, okay, solving for W, what do I need to do first? This is similar to the Adrian has a girlfriend problem, right? What do I need to do first? I've got the couple and I need to do what?
Divide.
Subtract away the 2L.
Oh.
Okay, so you got P minus 2L is equal to 2W. Alright, then I need to do what?
Divide by
by two. Okay, so you end up with P minus two L over two is equal to W. Okay, you cannot divide this two and this two. Okay, the P would also have to have a two as well if you were gonna simplify and get rid of those twos. Okay, but since the P does not have a two, it has to stay P minus two L over two. Alright, so very similar problem to 13 is 14. Okay, if I wanna solve for Y, what do I need to do first?
Minus 8.
Minus AX. Okay, and I get BY is equal to C minus AX.
And divide by B.
Divide by B,
Right.
and Y is equal to C minus AX over B. Alright, number 15, solving for X. What's my first step?
Divide. Subtract, yeah.
Subtract B. Okay, you've got Y minus B is equal to M times X
Divide the M.
by M. Okay, and you'll have Y minus B over M is equal to X. Alright, solving for T on 16, my first step is to subtract P. So we'll have A minus P is equal to PRT.
You're gonna divide by the PR, cause
Then you're gonna divide by PR. Divide by PR. Okay, and so you got A minus P over PR is equal to T. Alright, I'm not going to work 17 or 18 unless I need to, and when I say that, I'm gonna look at the Go Formative and see if there's a problem like that on Go Formative. If there is, I'll come back and work these. If not, we're just gonna leave those off, because that's a little bit more than I want to tackle today. So on Go Formative, y'all obviously are used to it from Bell Work, but the assignment today will be on there. Okay, it's 10 questions, and I'm gonna have it set to where it's gonna show you if you're gonna get the problem right or wrong immediately. Okay, so if you're working number one and you put your answer in and a red dot shows up, then you know you've got it wrong. If a green dot shows up, you know you've got it right. Okay.
will it show, can you say that will it show us our score too?
Well, you're gonna see your score as you're working it. Because if it's green, you've got it right. If it's red, you got it wrong. Okay. Does that make sense? All right, headed to Go Formative. All right, that's where your assignment is today, not kind of